Hello everyone, I am Xutong from Carnegie Mellon University. It is my great honor having this opportunity to share our recent work with you. The title is Can Prediction of Term Management Willingness Improve Term-Changing Modeling? This work is joined by my colleague Ishii, Michal, Muszynski, and Professor Louis-Philippe Morency. My presentation contains 5 parts. First, I will introduce our motivation and problem statement. After that, I will describe how we build our purpose and some empirical studies based on it. Next, I'm going to elaborate our term management willingness prediction and term changing prediction models, which is followed by some experimental results. Finally, I will give a conclusion on this work as well as some future steps. Our work focuses on turn-changing prediction. Turn-changing happens when the roles of speaker and listener change during their dialogue, while time-keeping happens when the speaker continues to speak. Turn-changing is an important aspect of conversation. Predicting turn-changing benefits conversational agents, as they need to know when is the appropriate time to take and yield turns in a human-computer interaction. Furthermore, accurately predicting turn changing helps agents to moderate multi-party conversations. For smoothing conversation, participants must carefully monitor the speaking and listening willingness of their partners and decide whether to make a turn changing based on that. So understanding of such term management willingness helps to make a smoothing turn changing. Researchers have been working on developing turn changing prediction systems using verbal and nonverbal information. Many studies focus on predicting turn changing on the basis of acoustic, linguistic, and visual cues. Some studies demonstrate that behaviors such as eye gazing, hand movement, and respiration contribute to turn-changing prediction. However, most studies predict turn-changing directly without taking into consideration of any term management willingness. But this psychological status is important for people to manage their turn-changing behaviors in a conversation. Therefore, it motivated us to formulate our research questions and incorporate the willingness prediction test to the turn-changing prediction system using 3 modalities. Our research tries to answer whether the prediction of term management willingness can improve turn-changing modeling. We split it into 2 questions. Are the verbal and nonverbal behaviors of speakers and listeners useful in predicting term management willingness? Furthermore, does explicitly modeling willingness help with turn-changing prediction? Note that there are 4 types of different term management willingness. Turn-holding willingness indicates speakers' willingness to continue speaking. Turn-yielding willingness indicates speakers' willingness for listening. Turn-grabbing willingness represents listeners' willingness to start speaking, and listening willingness is the listener's willingness to continue listening. We collected a new corpus that includes verbal and nonverbal information on human-to-human dialogues. There are in total 12 face-to-face conversations between Japanese people who had never met before. The conversations were structured to be about multiple topics, and the lengths were unified to be around 10 minutes each. During the conversation, we recorded their voices and upper body videos. Their utterances were transcribed by a professional annotator and double-checked by another one. To annotate willingness, conversations were first divided into utterance intervals. Then there are 10 annotators carefully watched each video from the beginning of one utterance to one frame before the next utterance. They were asked to give integer scores from 1 to 5 to each kind of willingness, without knowing who would become the next speaker. The high ICC values for 4 willingness scores show the agreement among 10 annotators. This indicates that the data and annotation are very reliable. In our experiments, we use mean values of 10 annotators' scores. Furthermore, we analyze the relationship between willingness scores and the actual turn changing or turn keeping as an empirical study. These two figures show box plots of each score in our corpus. When turn keeping happens, the average scores of turn holding willingness and listening willingness are very high. In contrast, those of turn yielding and turn grabbing willingness are very low. This suggests that a person's turn management willingness and the actual next speaking behavior are always consistent in turn keeping. However, when turn changing happens, all average willingness scores are close, with larger standard deviations. This means that willingness scores sometimes have discrepancies with actual turn changing. The current listener who becomes the next speaker may not always have a high turn grabbing willingness, and the current speaker who becomes the next listener may not always have a high turn yielding willingness. This result raises the importance of willingness prediction that could be helpful for agents to facilitate smooth conversation by reducing such discrepancies between the willingness and actual turn changing. To address our research questions, we implemented willingness prediction and turn changing prediction models. We first extracted highly abstract features from pre-trained deep neural networks because they are useful for small-sized datasets. We consider 3 modalities for both speaker and listener. For acoustic modality, we use VGG-ish, which is a deep neural network for audio classification. We use a GRU to encode features extracted from audio frames of an utterance into a vector. For linguistic modality, we use a multi-layer bidirectional transformer network, as known as BERT, followed by a fully connected layer to encode the transcription into a feature vector. For visual modality, an image classification network ResNet is used to extract high-level visual features, and similarly, a GRU is used to encode them. The models take features extracted from data within the time period of an utterance and make their prediction at the end of this utterance. To address our question 1, we implemented 3 kinds of models to predict term management willingness using multimodal features of only the speaker, only the listener, or both of them. For question 2, we implemented multi-task models for jointly predicting term management willingness and term changing on the basis of single task prediction models. In this figure is the structure of the multi-task model with acoustic, linguistic, and visual features of both speaker and listener. We first investigate and compare the performance of models with different feature sets to demonstrate that term management willingness can be predicted using multimodal behaviors of both speaker and listeners. We use the one-diode-out method to evaluate our performance and reported the CCC between predicted and actual willingness scores. Here, a higher CCC score indicates stronger agreement between the prediction and ground truth. The first row in the table represents a random level performance. By comparing Model 2 and 3, we found that Model 2 has higher scores for speakers' willingness, while Model 3 has higher scores for predicting listeners' willingness. This suggests that features from a participant are more useful for predicting his or her willingness than the other ones. If we compare Model 2 and 3 with Model 4, we find an overall improvement in willingness prediction. This suggests that a model using features of both speakers and listeners outperforms a model using those of single participants. Second, we analyzed the performance of multitask learning models and single-task models. We reported F1 score to evaluate turn-changing prediction performance. We consider each pair of models with same features but are trained either as a single model or multitask model. The comparison shows that whereas all three models of multitask learning outperform those of single task. This demonstrates that incorporating willingness into turn-changing prediction models improve their performance. In conclusion, our results show the boosting performance of using features of both participants and incorporating willingness prediction into turn-changing prediction models. Therefore, our answer to the first research question is that features from individual him or herself, as well as those from his or her conversational partners, are greatly useful in predicting internal willingness in a dialogue interaction. For question 2, we find that turn-changing prediction becomes most accurate when it is predicted simultaneously with turn management willingness using multitask learning. Therefore, explicitly adding willingness as a prediction target improves the performance of turn-changing prediction. Our results show that prediction of psychological status improves the performance of physical behavior prediction. Multitask learning lets a model to learn the underlying relationship between turn management willingness and turn-changing behaviors. It inspires us to more accurately predict human behaviors by predicting psychological status at the same time. Furthermore, our study demonstrates that there are discrepancies between turn management willingness and actual next speaking. It means that prediction of turn management willingness can enable intelligent agents to facilitate people who have no chance to speak, even when they have high willingness of speaking. In the future, we plan to research on other interpretable features such as eye gazing and hand movement. Meanwhile, we plan to implement prediction models that take into consideration of temporal relationships. We also plan to incorporate prediction models into conversational agent systems that can help the smoothing turn changing and facilitate the state of speaking for participants. Thank you for your listening. Are there any questions?